Welcome to our introduction on demystifying machine learning. Machine learning is a branch of artificial intelligence, or AI, focusing on enabling computers to learn from data. Imagine a computer program that can predict your next online purchase. This is possible with machine learning. The program analyzes your past browsing and purchase history, allowing it to identify patterns and make predictions. It helps doctors diagnose diseases with higher accuracy, assists financial institutions in detecting fraud, and even powers self-driving cars. At its core, machine learning relies on algorithms, which are sets of instructions that computers follow. These algorithms process and analyze large amounts of data, identify patterns and relationships, and make predictions or decisions. As the algorithms are exposed to more data, they learn and adapt, enhancing their accuracy and performance. Now let's explore the building blocks. Data as the foundation. Data is the lifeblood of machine learning. It is the raw material that algorithms use to learn and make predictions. Just like humans learn from experiences, machines learn from data. The quality and quantity of data directly impact the performance of machine learning models. Data can come in various forms, including text, images, videos, and numbers. For example, a machine learning model designed to translate languages would be trained on a massive data set of text and translations. Before feeding data into algorithms, it needs to be processed and cleaned. This step is crucial for ensuring the accuracy and efficiency of machine learning models. Generally, more data leads to better performance as algorithms have more examples to learn from. However, the quality of data is equally important. Moving on to Section 3. Algorithms, the brains of the operation. Algorithms are the heart of machine learning. They are the sets of rules and mathematical models that enable computers to learn from data. Think of algorithms as recipes that guide the learning process. Different algorithms are suited for different types of tasks and data. One common type of algorithm is the decision tree. As the name suggests, it uses a tree-like structure to make decisions based on the input data. Another widely used algorithm is the neural network. Inspired by the structure of the human brain, neural networks consist of interconnected nodes, neurons, that process and transmit information. Neural networks excel at recognizing complex patterns and are used in tasks like image and speech recognition. The choice of algorithm depends on the specific problem being solved and the characteristics of the data. Finally, let's discuss Section 4. Types of machine learning, learning from data. Machine learning can be broadly categorized into three main types: supervised learning, unsupervised learning, and reinforcement learning. Each type differs in how it learns from data and the problems it aims to solve. Supervised learning is like learning with a teacher. The algorithm is provided with labeled data, meaning each input data point is associated with a known output or target. The goal is for the algorithm to learn the mapping between the input and output, so it can predict the output for new unseen data. Unsupervised learning, on the other hand, is like learning without a teacher. The algorithm is given unlabeled data and tasked with finding patterns and structures within the data. Reinforcement learning is like learning through trial and error. Welcome to Section 5, Supervised Learning, learning with a teacher. Supervised learning is a type of machine learning where the algorithm learns from labeled data. This means that for every input data point, there is a corresponding output or target label. The goal of supervised learning is to train the algorithm to learn the mapping between the input and output, so it can accurately predict the output for new unseen data. One common example of supervised learning is spam filtering. In this case, the input data would be emails, and the output label would be whether each email is spam or not. The algorithm would be trained on a dataset of emails that have been manually labeled as spam or not spam. Once trained, the algorithm can then classify new emails as spam or not spam. Another application of supervised learning is image recognition. Here, the input data would be images, and the output label would be the object or scene depicted in the image. Supervised learning algorithms can be further divided into two main categories: classification and regression. Now let's dive into Section 6, unsupervised learning, discovering hidden patterns. Unsupervised learning, in contrast to its supervised counterpart, operates on unlabeled data. This means that the algorithm doesn't have the luxury of pre-assigned outputs or target labels. Instead, it dives headfirst into a sea of data points, tasked with unearthing hidden structures, patterns, and relationships. One of the most common tasks in unsupervised learning is clustering. Just as the name suggests, it involves grouping similar data points together based on shared characteristics. Another important application of unsupervised learning is dimensionality reduction. In many real-world datasets, the number of features or variables can be overwhelming, making it computationally expensive and difficult to extract meaningful insights. Dimensionality reduction techniques aim to reduce the number of features while preserving the essential information. Unsupervised learning also plays a crucial role in anomaly detection. Moving on to Section 7, Reinforcement Learning. Learning by trial and error. Reinforcement learning takes inspiration from how humans and animals learn through trial and error. Imagine a child learning to ride a bike. They try different approaches, receive feedback in the form of balance or falls, and gradually improve their skills over time. Reinforcement learning algorithms follow a similar principle. In reinforcement learning, an agent interacts with an environment and learns to take actions that maximize a reward. The agent observes the state of the environment, takes an action, and receives a reward based on the outcome of that action. This process is repeated iteratively, with the agent learning to choose actions that lead to higher rewards over time. One classic example of reinforcement learning is teaching a computer to play games. The agent, in this case, the game-playing AI, observes the game state, takes actions, and receives rewards based on the game's outcome. Through repeated play, the agent learns optimal strategies to maximize its chances of winning. Reinforcement learning has found applications in various domains, including robotics, control systems, and resource management. Section 8. Real-world applications AI in our daily lives. Machine learning has seamlessly integrated into our daily lives, often without us even realizing it. From the moment we wake up to the time we go to bed, AI-powered applications are constantly working behind the scenes, enhancing our experiences and simplifying our tasks. One area where machine learning has made significant inroads is personalized recommendations. Streaming services like Netflix and Spotify use machine learning algorithms to analyze our viewing and listening history, recommending movies, TV shows, and music tailored to our tastes. Similarly, online retailers like Amazon use our past purchase and browsing data to suggest products we might be interested in. Another domain revolutionized by machine learning is natural language processing, NLP. Virtual assistants like Siri, Alexa, and Google Assistant rely on NLP to understand our voice commands, answer our questions, and perform tasks like setting reminders or playing music. Machine translation services like Google Translate use NLP to break down language barriers. Machine learning is also transforming the healthcare industry. Section 9. The impact and ethics of machine learning. The rapid advancements in machine learning have sparked discussions about its impact on society, both positive and potentially negative. As with any transformative technology, it's crucial to consider the ethical implications and ensure its responsible development and deployment. One concern is the potential for job displacement. As machine learning algorithms become more sophisticated, they are capable of automating tasks previously performed by humans. While this can lead to increased efficiency and productivity, it also raises concerns about unemployment and the need for workforce retraining. Another ethical consideration is bias in machine learning algorithms. If the data used to train these algorithms is biased, the resulting models will also be biased, potentially leading to unfair or discriminatory outcomes. Privacy is another important concern. It's crucial to establish clear guidelines and regulations regarding data collection, storage, and usage to protect individual privacy. Section 10. The future of machine learning, a glimpse ahead. The field of machine learning is constantly evolving, with new breakthroughs and applications emerging at an astonishing pace. As we look ahead, several trends and predictions offer a glimpse into the future of AI. One trend is the increasing availability of data. With the proliferation of sensors, connected devices, and online platforms, the amount of data being generated is growing exponentially. This data explosion is a boon for machine learning, as it provides more fuel to train sophisticated and accurate models. Another trend is the development of more powerful hardware. Advances in computing power, particularly in areas like GPUs and specialized AI chips, are enabling researchers to train more complex models and tackle more challenging problems. The rise of quantum computing is another exciting development that could revolutionize machine learning. As machine learning continues to advance, we can anticipate more intelligent and autonomous systems that can learn, adapt, and make decisions with minimal human intervention. Section 11. Conclusion: Embracing the AI revolution. Machine learning, a cornerstone of artificial intelligence, is revolutionizing our world at an unprecedented pace. From personalized recommendations to medical diagnoses, AI-powered applications are transforming industries and shaping our daily lives. Understanding the basics of machine learning is no longer a luxury, but a necessity for navigating this rapidly evolving technological landscape. By demystifying concepts like algorithms, datasets, and the different types of machine learning, we can empower individuals to embrace the AI revolution and harness its potential for good. While ethical considerations and potential challenges remain, the transformative power of machine learning is undeniable. As we move forward, it's crucial to foster collaboration, promote responsible AI development, and ensure that the benefits of this technology are accessible to all. By embracing the opportunities while addressing the challenges, we can shape a future where machine learning empowers humanity and creates a more just, equitable, and sustainable world.